Alright, so this is 3.4C in college algebra, and we're ready for example 6. Okay, you ready? We are finding the zeros, both rational and irrational, and then we're going to write the factors once we find the zeros. Alright, so remember I talked to you about the P over Q in the last one? Well, that's what we're going to do. P over Q. So we've got 15 over 2. So I'm going to find the factors of 15, and that's a positive 1 times positive 15, negative 1 times negative 15, positive 3 times positive 5, negative 3, negative 5. Okay, these are all the different options that are going to give me 15. And what about 2? Positive 2 times positive 1, or negative 2 times negative 1. So I'm going to write these a lot simpler here. I'm going to put plus or minus 1. That gets rid of that one and that one. Plus or minus 3. That gets rid of that one and that one. Plus or minus 5. And plus or minus 15. And down here we have a plus or minus 1 and a plus or minus 2. So now we have to look at all of these over 1, all of these over 2, and then go from there. So let's go ahead and make a list here. We'll do that in white. So we have 1, negative 1, 3, negative 3, because these I'm looking at all the numbers over 1 and negative 1. Okay, now let's put 1 over 2 and over negative 2, so we have 1/2, we have negative 1/2, we have 3/2, we have negative 3/2, and we have 5/2, negative 5/2, we have 15 over 2 and negative 15 over 2. So all of those numbers are ones we have to look at to determine whether or not any of those are zeros. So again, we start with the whole numbers and try those out, and then we go to the fractions. So remember, we have 5 answers. 3 are going to be in here, and then we've got an x squared, so that would be a good place to go. Okay, so I'm not going to go through the synthetic division of every stinking one of these, so let's just go ahead and at least write 2, negative 1, negative 4, positive 2, negative 30, positive 15. Okay. And then we've got to decide what numbers we're going to do. Well, the book puts 1 in there. It puts 1 in here, and they find out it has a remainder. So 1 does not work. So 1 we throw out. Negative 1 also doesn't work. We end up using a whole bunch of other numbers, and finally they get to 1/2. So they put in 1/2. So they get 2, 1, 0, 0, negative 4, negative 2, 0, 0, negative 30, negative 15, 0. Okay. Okay, so negative, or 1/2 ends up being one of my factors. Okay, so let's write what I have right now using that 1/2. I have x minus 1/2, because I found out that works. And what do I have left? 2x to the fourth minus 0x cubed minus 4x squared plus or minus 0x minus 30. Oops, sorry, I forgot the 4 right there. Okay, so this is what I have to work with. These are my factors of my original problem clear up here. Okay, but this is not a linear factor yet, so we need to keep reducing that down. Alright, so I'm going to move everything out of here except for these two right here, and we'll keep going from there because there's this little trick going on there. Okay, so this is what I ended up with. One factor here that's linear. This one is not linear because I have exponents. So I've got to keep going. This is a 4. It needs to be a 2. So I've got 2 more factors to pull out of that in order to get this to be a 2, a quadratic here. So I'm going to pull a 2 out of here first. Yeah, come on, Gary. Let's make a 2 there. Okay, so if we were to rewrite this, we've got 2x minus 1/2 times x to the fourth minus 2x squared minus 15. Alright, let's look at this. Now, normally we would keep doing synthetic division, but one of the things that I noticed that, it's going to take practice for you to notice that when I have even exponents, like here, a 4 and a 2, or if I had a 6 and a 3 or something like that, I can use a little trick here so that I don't have to do any more synthetic division. And that little trick is, we've already done it a couple times, is I take the middle term, or the middle variable with its exponent, and make it equal to u. So I have x squared minus, 2x squared minus 15, and I'm going to use this principle right here, and I'm going to put in a u wherever I see an x squared. Okay, so I've got that, and I break this down into two binomials. So that gives me u and a 5 and a u and a 3. So that gives me a u minus 5 and a plus 3. Now I'm going to put my x squared back in there. Okay, and I still have the 2 and the x minus 1/2 over here. These just pull down with it. Okay, so now we keep going. I need to continue to solve this because these are not linear yet. So I have x squared equals 5, or x equals plus or minus the square root of 5. And x squared equals negative 3, so x equals plus or minus the square root of 3i. Okay, so I have one 0 that I found earlier that's 1/2, and I wrote it as x minus 1/2. I have another 0 that's positive square root of 5, another one that's negative square root of 5, a positive square root of 3i, and a negative square root of 3i. So I have 1, 2, 3, 4, 5 answers there. And that's what I started with, was an x to the 5th power. Alright, so those are all of my answers. Now, the book asks me for part B, write it as linear factors. So, sorry, I'm kind of bouncing things around, trying to get rid of stuff so I can move things up. Nah, didn't want to get rid of that. Alright, so, I've got those two. So, 2x minus 1/2. Now I need to write these as factors. X minus the square root of 5, x plus the square root of 5, x minus the square root of 3i, and x plus the square root of 3i. There is my linear factors. That's where it crosses the x-axis. It crosses at these three places, does not cross at those two because those are complex numbers. All right, lots of really crazy stuff. I hope that you're kind of catching on here. All right, I'm going to stop this video, C, and I'm going to do one more. Hopefully it'll only be one more, and it will be D, and we're going to do Descartes' rule of signs on the next video.